Hi everyone and welcome again to our World HVAC. In this video I'm going to talk about types of maintenance for HVAC equipment. There are different types of maintenance that organizations use to increase the uptime of their assets and utility of their facilities. Based on an organization's budget, amount of resources, level of combined experience, and maintenance goals, one or more maintenance types are used. Mainly we have two types of the maintenance. We have proactive types of maintenance, which is before the breakdown of the equipment, and we have reactive type of the maintenance, which is after the breakdown. So the proactive types are preventive maintenance, predictive maintenance, condition-based maintenance, scheduled maintenance, planned maintenance, and routine maintenance. The reactive types are emergency maintenance, corrective maintenance. The first type of the proactive types is the preventive maintenance. Preventive maintenance is a type of proactive maintenance that includes adjustments, cleaning, lubricating, repairs, and part replacements. PM aims to keep assets in good order and reduces unscheduled shutdowns and sudden major repairs. Second, predictive maintenance. Predictive maintenance (PDM) is what savvy maintenance teams aspire to have or already implementing. Predictive maintenance (PDM) is a type of condition-based maintenance that monitors the condition of assets using sensor devices. These sensors devices supply data to real time, which is used to predict when the asset will require maintenance and prevent equipment failure. Predictive maintenance workflow. This workflow includes establish baselines. The maintenance team establishes acceptable condition limits for assets that will have sensors. Install IoT Internet of the Things devices. The relevant sensors is affixed to the asset. For instance, a vibration meter is affixed to mechanical asset with gears, and a temperature sensor is attached to a boiler. Third, connect devices to software. The IoT devices is connected to a CMMS or remote dashboard where data is collected and analyzed. Schedule maintenance. Inspections are automatically triggered by a CMMS when the condition limit is exceed or the person monitoring the dashboard schedules the inspection manually. The third type, condition-based maintenance. Condition-based maintenance, CBM, is the core of predictive maintenance, but on its own does not rely on technology to determine the condition of an asset like DPM does. Condition-based maintenance, CBM, use sensor devices to collect real-time measurement, i.e. pressure, temperature, or vibration. On a piece of equipment, CBM data allows maintenance personnel to perform maintenance at the exact moment it is needed prior to failure. Scheduled maintenance. Scheduled maintenance includes work that is scheduled on a calendar for completion. The most common type of scheduled maintenance is a calendar-based preventative maintenance tasks. Scheduled maintenance is any repair and upkeep work performed within a set time frame. It details when given maintenance tasks are performed and by whom. Scheduled maintenance may occur at repeating intervals or in response to a work request. Scheduled maintenance workflow. Scheduled maintenance often occurs at repeating intervals, such as changing an air filter every March and September, or conducting a performance inspection at the start of each year. Maintenance may also be scheduled to fulfill a work order. Once a problem is discovered, a maintenance scheduler works with a maintenance planner to resolve the problem. A time is then scheduled to conduct necessary repairs. Next, planned maintenance. Planned maintenance is work that's prepared for in advance of it taking place. According to an upkeep survey, it's also the most popular key performance indicator (KPI) to track. Planned maintenance is the process of detailing what materials, tools, tasks, and services are required to solve a problem. The purpose of planned maintenance is to determine what work needs to be completed and how it needs to be done. Planned maintenance starts with a problem and identifies the materials, tools, and tasks necessary to work on the problem. The planning process involves inspections, part ordering, process descriptions, and work prioritization. These responsibilities fall on the maintenance planner's shoulders. The planned maintenance program for a facility may include scheduling, but sometimes scheduling occurs separately via a maintenance scheduler. Planned maintenance workflow. The workflow for planned maintenance involves several steps, include first, identify the problem and create a work order. Second, inspect the asset and premises where work will be performed. Third, order the necessary parts and prescribe a process to complete the work. Fourth, add a priority level to the work order. This includes actually low or medium or high. And fifth and finally, schedule and complete planned maintenance. And last type of proactive maintenance is routine maintenance. Routine maintenance is a form of time-based maintenance and preventive maintenance, though some organizations differentiate between routine maintenance and preventive maintenance. They use the latter for smaller tasks, for example, cleaning, performed at higher frequencies, hourly or daily, and the former for larger tasks. For example, inspections, which performed at lower frequencies, weekly or monthly or annually. Additionally, routine maintenance is performed by operators, janitors, and other staff members, while preventive maintenance is performed by technicians. Non-routine maintenance includes maintenance that is performed reactively or only when needed based on an asset's conditions. So routine maintenance are maintenance activities such as regular inspections or machine servicing. Routine maintenance is done on a regular basis, whether that be daily, weekly, or monthly, or yearly. Routine maintenance is an important part of keeping systems up to date and functional. Routine maintenance workflow. Routine maintenance tasks are small and simple in nature and only require basic maintenance skills to perform well. They may be completed daily, weekly, monthly, quarterly, or annually. Companies that invest in routine maintenance can extend the life of their assets, reduce emergency maintenance, and keep their production lines or facilities up and running more consistently. Routine maintenance is a type of a preventive maintenance and also a key part of total productive maintenance, in which machine operators perform small maintenance tasks to increase the reliability of the machine they use every day. Second type of maintenance is reactive type maintenance, which occurs after the breakdown of the equipment. We have two types of this maintenance. We have emergency and corrective maintenance. Emergency maintenance occurs when an asset requires immediate attention in order to keep a facility operational or safe. Emergency maintenance is a type of reactive maintenance that is used to prevent a threat to lives, property, profitability, or viability of an organization. Emergency maintenance workflow. Whether in an industrial or residential setting, emergency maintenance EM is required when lives, property, or assets are under immediate threat. In a processing plant, for example, EM is applied to keep facilities safe and operational. In tenancy situations, EM protects the health and safety of residents as well as the building's assets. EM can reach more than double the expense of a regularly implemented preventative program. Second, corrective maintenance. Corrective maintenance is inherently part of emergency maintenance because when there is an emergency, something needs corrected or fixed. In this way, corrective maintenance is mostly reactive. However, it can also be proactive. If an asset with a condition monitoring sensor detects an issue, a work order is created and a technician is sent to correct it. Corrective maintenance is the category of maintenance tasks that are performed to rectify and repair faulty systems and equipment. The purpose of corrective maintenance is to restore systems that have broken down. Corrective maintenance can be synonymous with breakdown or reactive maintenance. Corrective maintenance workflow. Corrective maintenance orders are typically initiated when an additional problem is discovered during a separate work order. For example, if maintenance technicians spot an issue during an emergency repair as part of routine inspection or in the process of constructive preventive maintenance, that issue can turn into a corrective maintenance order.
Let's have an idea about chiller maintenance procedures. We have the main chiller components for check are the compressor. We need to have a look to startup of the chiller. We need to see if it has some requirement for maintenance. Some centrifugal chillers also suffering from surge. We need to check the pressure as well as the temperature of the compressor. Evaporator, we need to have a look to the pressure, temperature, and corrosion. Condenser, we have to check the pressure, temperature. We need to see if it is scaling inside the condenser. Corrosion, loop, condenser coil cleaning, we need to do it annually. Tube brushing as well, and water treatment. Motor and starters, we need to check if there is overload, high amps. We need to analyze compressor oil annually. We need to change the oil as well as oil filter. Microprocessor electrical control. Monitor the refrigerant leak in case there is a leak. We need to do the refrigerant analysis. Shaft seal and bearing lead to increased temperature. We need to calibrate water temperature sensors. We need to check the refrigerant low pressure cutout. We need to check condenser high pressure cutout not exceed 275 seg. We need to check auxiliary oil pump control. The auxiliary oil pump should start if the differential pressure falls to or below 23%. Means differential. The auxiliary pump will stop when the oil pressure rises above 27 psid. We have the standard checks also for chillers. Temperature and pressure sensors are there. The unit comes factory equipped with all the sensors listed below. Periodically check that their measurements are correct by means of reference instruments, manometers, thermometers. Correct the wrong readings as necessary using the operator interface panel. We will calibrated sensors ensure better efficiency for the machine and a longer lifetime. Note: refer to the operating manual for a complete description of applications, settings, and adjustments. All sensors are pre-assembled and connected to the microprocessor. The descriptions of each sensor are listed below. We have the evaporator outlet water temperature sensor, which is located on the evaporator outlet, water connected, and is used by the controller to control the unit load depending on the system thermal load. It also helps control the evaporator antifreeze protection. We have the evaporator inlet water temperature sensor. This sensor is located on the evaporator inlet water connection and is used to monitor the routine water temperature. We have the evaporator differential pressure switches. Two sensors are located between the evaporator inlet and outlet water connections and is used to protect evaporator against loss of water flow. We have condenser inlet water temperature sensor. This sensor is located on the condenser inlet water connection and is used by the controller to control the tower bypass valve depending on the system thermal load. We have the condenser inlet water temperature sensor. This sensor is located on the condenser outlet water connection and is used for monitoring the leaving water temperature. We have the condenser differential pressure switches. Two sensors are located between the condenser inlet and outlet water connections and is used to protect condenser against loss of water flow. The following sensors are located inside the compressor and managed by the compressor integrated electronic controller. We have the compressor discharge pressure transducer. We have the compressor discharge temperature sensor. We have the compressor suction pressure transducer and compressor suction temperature sensor. Here we have the temperature sensor for the evaporator as well as the condenser. And we have the differential pressure flow switch. Let's have an idea about chiller system preventive maintenance checklist inspection. In this type of inspection, we have to do some annually inspection checklist, including monitor system for correct phase, volt, amperes, inspect frame, fit and finish, and proper clearance, monitor system starting characteristics, run to settings, inspect unit for proper refrigerant level and adjust if necessary, measure high and low side system pressures, inspect fan motor and fan blades for wear and damages, inspect all electrical connections, inspect all test contactors, relays as well, inspect compressor and associated tubing for damages and leaks, inspect evaporator coil, drain pan and condensate drain line leaks, inspect heat exchanger or heating elements, inspect all plumbing fittings in unit for leaks, inspect pumps and filters, test glycol, listen to abnormal noises, search for source of unusual odors, inspect coil and cabinet cleaning available for an additional charge, monitor system operation per manufacturer's specifications, verify thermostat settings and cycle chiller to verify proper sequence of operation upon completion, start and run system under load, finally install correct labels. We have also another checklist. After start up of the chiller, we have to note down all the parameters which is in the field of operation of the chiller. During startup of the chiller, we have to record all of these numbers, including voltage, including motor amps, including suction pressure, discharge pressure, and also motor amps, and finally ambient temperature at start up.